Trifecta is the global leader in data wrangling software. Leveraging decades of innovative work in human-computer interaction, scalable data management, and machine learning, Trifecta's unique technology significantly enhances the value of an enterprise's big data by enabling users to easily transform and enrich raw, complex data into clean and structured formats for analysis. By reviewing the logos on this slide, you'll see that we're working with some of the leading organizations in their respective industries. The common attitude across all of our customers is their focus on leveraging data to drive innovation and bring value back to the organization. We're excited to play a central role in the big data and analytics strategies of these organizations. Data preparation, or what we call data wrangling, is widely recognized as the most difficult and time-consuming aspect of the end-to-end analysis process, taking up to 80% of the overall work effort in any analysis project. This is what Trifecta focuses entirely on, reducing that time by a factor of 10 while delivering a better outcome. Wrangling is the process of converting diverse data from their raw formats into a structured and consumable format for business intelligence or statistical modeling tools. What is unique with Trifecta is that the overall experience is accessible to non-technical users in a seamless and self-service way. Trifecta automatically discovers the data, structures it in a familiar grid interface, and identifies the potential invalid data and suggests the best way to clean and transform your data. Trifecta learns from the user interaction, providing immediate feedback to the interactions to better guide the user in enriching and validating the data at scale so it can be published with confidence to the next stage of the analytical process. Trifecta sits between the data storage layer, whether that's standard systems or a Hadoop platform, and the visualization or machine learning applications used downstream in the process. Let's now jump into a particular use case where you can see the unique user experience in action. In this demo, I will play the role of a telco data analyst who needs to combine various and complex data sets together to produce as many predictors to build and tune a predictive model to identify the reason customers may churn and prevent it before it happens. With simplification in mind, the demo will only focus on customer information that is coming from a transactional system, account activity, and more specifically the call detail record log that contains information such as unwanted dropped calls, and social media activities, in particular tweets referencing US Telco, from which I can derive a sentiment score, which can be a good churn predictor. I will be leveraging Cloudera Enterprise Data Hub to search, store, process, and access the data at scale. Trifecta sits on top of Cloudera to discover and profile the data, and then structure the complex data into discrete attributes, so it can be cleansed, normalized, enriched, and combined with additional data sets to be distilled in a way that BI tools or other machine learning frameworks can leverage the data. The demo will focus on the particular process of preparing the data from Hadoop so it can be consumed for predictive modeling. The data I'm working with are in different file formats, which are complex and often changing. It is hard to clean the data and derive insights, such as sentiment scores from a conversation. To add to this complexity, these come in huge volumes, so I can hardly manipulate the data. I've been relying on programming languages and ETL data engineers to do this work for me. Because they don't know the context of the data, my current process creates far too many frustrating cycles before I can actually get the data right and provide insight to my business. With Trifecta, let's see how I can easily format these files into discrete attributes so I can derive insight quickly. Let's start with the customer data that is coming from our transactional system. This is pretty well structured. As a data analyst, pulling up this data in Trifecta, I'm immediately presented with the data in a familiar grid interface. Trifecta automatically identifies signals in the data to split columns and lines. It also automatically infers the data type of each column and presents a data quality bar communicating the relative quality for each attribute. In this particular case, Trifecta was able to detect the comma as a separator and identify the header for each column. Data types have also been inferred automatically. Let's take a closer look at our customers. I'm taking a look at the customer details here in the state column. I'm presented with the data distribution and statistics such as the min and max size, and a visual distribution of the data in the US. Because I'm interested in churn prediction, there's no need to keep inactive customers in my data set, so let's select the inactive customers. Thanks to predictive interaction, Trifecta identifies the user's actions to recommend the best transformations to be applied to the dataset. For example, splitting or extracting a column, keeping or deleting rows, or replacing patterns in a column. Trifecta visually shows the distribution and suggests that I keep the data I selected, but in this particular case, I will select delete instead of keep. Let's now switch to the CDR log so we can also format it and combine it with customer information. The CDR log is a way more complex structure and in theory more difficult to handle. Let's see how easy it is with Trifecta. Look at how Trifecta is able to learn by example. I first select the IMSI, and Trifecta suggests a transformation for me. Then I brush a number, and it's getting closer to what I want. And when I finally select the third value, Trifecta got the exact solution across rows that I was looking for. Notice how easy it is to format the columns. Trifecta's inference engine deduces metadata to the specific data type for each attribute and presents a data quality bar communicating the relative quality of each attribute of the data. We're also presented with an intuitive visual representation of the data distribution in each column in the form of a histogram that shows relative frequency of terms. Let's clean up our file a little bit more. We're almost done in formatting the file into discrete values. Trifecta is telling me that some values do not conform by adding a red square to the header of the column. By clicking the value, Trifecta highlights the mismatched rows. In this case, we want to convert these values into the dataset's header. We now have two datasets that are pretty well structured. We were able to discover and format a complex file in only a couple of minutes. This will improve the data analyst's productivity and ultimately accelerate the time to value of his work by limiting the frustrating back and forth process with IT. Trifecta's self-service predictive interaction empowers the data analyst to be more productive and provides faster value to the business. With this structured format, the data analyst can now discover in greater detail what the data can reveal. In addition to its unique predictive interaction ability, Trifecta enables the user to discover the data and clean it through interactive profiling. This will bring the data to the next level of accuracy for trusted and focused analysis. In this use case, the data analyst will be researching dropped calls in order to prepare the data to research possible customer churn. You will see through interactive profiling what the data distribution is, whether or not there are outliers, what data correlations are present, and what anomalies need to be remediated. Going back to the CDR log file, I can see from the column header that Trifecta inferred the IMSI as an integer data type, and that some data does not fit that category. By clicking the red zone in the header, I can identify quickly what data doesn't comply. It appears that I have some dashes that I don't want. Let me brush over the dash. Trifecta suggests a few transformations, and I want to select Replace. Let me add this transformation to the script. Because I'm interested in dropped calls that may be a factor of churn, I will try to isolate this information to identify from further analysis some possible repetitive patterns. As I continue browsing the column header, I can quickly identify that some data is missing from the column Disconnect Reason. By clicking missing values on the column header, I can see that it relates to call type SMS and MMS. I want to get more information about call type now. By selecting column details for call type, I can access statistical information about that particular column, such as mismatch values, value distributions, min, max, etc. Since SMS and MMS are not calls, they're not important to my analysis. If I click on SMS, Trifecta suggests me to keep the values. Instead, I want to delete them. I'm going to do the same for MMS. Whoops, I just added keep instead of delete. Luckily, that's not an issue with Trifecta. You can always reverse the script at any point in your transformation. Let me undo and then add the delete transformation to the script. What I've just achieved is called interactive profiling. At any moment during my data exploration, Trifecta profiles the data in real time and provides me with statistical information, distributions, type inference, anomalies, or missing value information. I can interact with the profile result and add to the Wrangler script so it becomes an active transformation to the datasets. Unlike any other technology, Trifecta provides active profiling that can transform the dataset. Now that I've cleaned up my CDR data, I can now work on preparing my next dataset. I will focus on the tweets my company is collecting continuously to derive a sentiment score. This information is also unstructured and needs to be formatted into discrete values so I can apply some natural language processing algorithm to derive a sentiment score out of the conversations, which I can then use as a predictor for my churn model. Twitter provides the feed using a JSON format. JSON is a semi-structured format containing value pairs, lists, and objects. Similarly to the CDR data, I will start to structure the file into discrete values so I can derive some insight. Trifecta automatically inferred the structure to be JSON and presents one column containing two objects, Twitter info and Twitter user. I brush the two bars and Trifecta suggests to unnest the columns. I am accepting the suggestion by adding it to the script, and so I drop the initial column. I mouse over the first column to discover what information is available and select the Twitter text value. I select the unnest transformation and drop the initial column. I now mouse over the column 1 Twitter user info to extract the user ID. I unnest and drop the initial column. Now that the data has been structured and cleansed, it's possible to enrich, standardize, and combine all these data sets in a superset that can be used in my model. Trifecta provides join, lookup, aggregate, and other advanced functions to enrich my dataset. We'll see how to create a sentiment score with a user-defined function, normalize columns with cross-reference lookup, and join datasets together and discover the value of inner-left joins. Let's go back to the Twitter feed file where we left it. We now want to derive a sentiment score based on the tweet text. With Trifecta, I can call a user-defined function to extend Trifecta language. In this case, I'm using a Python public library from www.nltk.org, a very used and recognized natural language processing library. In the transform editor, I can directly enter the Wrangling script. Look how Trifecta also guides me in suggesting the correct syntax. I can add the transformation to the script. The function returns a JSON format with a general trend for the message, negative or positive, and then the respective negative and positive score. I can now click on the histogram on the negative value and only unnest this particular value pair from the object. I then add it to the script and drop the PySentiment analysis column. I now brush over the long tail of negative values just to focus on the high negative sentiments to keep those ones from my model. I add the keep suggestion from Trifecta to my script. Reading the comments, I can see that the comments are actually negative. This information will be a great predictor to build my model. Moving back now to the CDR file, I will translate disconnect reason code into a descriptive label that non-specialist users can understand. I'm using the lookup function, and I select the drop code cross-reference table. As you can see, Trifecta added an extra column with plain English labels. Let's now combine the CDR log with the customer data that we already wrangled. I can join it with the CDR dataset to augment it with some new predictors. Clicking on the hammer icon, I have the option to join or aggregate data. I will use the join wizard to help me with that. I'm now offered a list of datasets that I can join it with. Let's select customer and preview the new dataset and then begin to join. Trifecta automatically infers the best columns that can match between the datasets based on content and format. It suggests IMSI as the best match column. Let's now add the sentiment score from Twitter to this combined dataset to create a superset that I can use in my predictive churn model. Selecting the hammer as I have done for the previous join, I'm now adding Twitter to the dataset. This time, Trifecta didn't find the best column to match. This is probably due to the fact that too few people have Twitter accounts. However, we can edit the join criteria to select manually the column to match. By selecting Twitter as the join criteria, I can now see the corresponding values. I can also see that the resulting dataset for the join will be reduced, the reason being that not all customers have known Twitter accounts. In order to keep all the customers, even if the join condition is not verified, I changed the join condition to left outer join. It will keep all customer data, even if the join is not verified. You can see now that the resulting set is way larger. I'm saving my condition, as I'm happy with it. I don't need all the columns to be in my resulting data set, so let me remove the Twitter ID and Twitter text from the columns and add to the script. Here we go. I've now combined CDR data, customer details, and their sentiment scores. This will be very useful to find some churn patterns. By augmenting, normalizing, and combining multiple data sets of various formats, the data analyst got to create a comprehensive view of the customers. More predictors are now available to detect churn and use for analysis. Row data, even cleaned and formatted correctly, is not enough to deliver all its business potential. Data has to be enriched, correlated, and standardized in a way that people can understand it. The more comprehensive the data is, the deeper the insight will be, better allowing data products to be accurate and robust. Now that I have a decent and trusted data set to work with, I may want to apply my wrangles to the full data set and make sure that my transformations are robust. With huge volumes of data, it's impossible for anyone to comprehend the whole set all at once. Trifecta proposed intelligent execution, so the data analyst works on a representative and manageable data set, then applies his rules on the whole set for comprehensive validation. The user can then expose the data to business users through BI tools or other preferred publishing mechanisms. Through Trifecta intelligent execution, we will discover how self-service can be extended to huge amounts of data and how it can be exposed to other users. You will see how to sample data, run transformations at scale on Hadoop, see the results, and re-ingest anomalies back to the sample, then publish the dataset in various formats such as SQL and Tableau. Let me go back to the transformer window. As you can see from the top of the screen, I've been working on the top first row of the dataset, but since then I've removed some rows and joined the CDR data with customer data, so the data distribution may not be reflected anymore. I can refresh the data to get a better targeted set and continue my preparation work. Trifecta is creating a new sample data set behind the screen, and so I can continue working. When the sample will be ready, I'll be able to refresh my working space. Let's now assume that I'm happy with my current transformation work. I want to apply my wrangling rules to the whole data sets. I can run the job locally, so Trifecta will execute the job, or if the amount of data is really large, I can leverage the unlimited power of Hadoop to run the job. I previously ran the job, so I'll analyze the results of this. In the job results screen, I get a good overview of the data set. First, the number of rows, the size that was processed, and then the data type and distribution of each column. What strikes me immediately is the percentage of anomalies and missing values. Trifecta displays some sample rows to demonstrate what data has these issues, and I can now ingest back these sample rows into my transformation project to further refine my rules. Let me click the Add Sample Rows to Transformer so this data is brought back to my project. I may also want to share my work with the rest of the team, or just export it so it can be used for another process, such as building the model for predictive churn. By clicking Export Results, I'm offered to export the dataset as a JSON or CSV file. I can also create a Tableau TDE file that is native to Tableau. Ultimately, I can give a name to the table that will be created in the H catalog, which is the way to access the data through SQL and Hadoop. This will enable me to connect any BI tool supporting SQL for reporting. By combining multiple data sets of various formats, the data analyst got to create a comprehensive view of the customers, though more predictors are available to detect churn. When it comes to making decisions on data, it's important to have the complete perspective and not to base it on partial information. Trifecta allows the data analyst to achieve his preparation at scale on virtually any volume of data. Ultimately, basing analysis on comprehensive datasets helps to ensure accurate and trusted business decisions. We were able to discover and structure complex formats thanks to predictive transformation and interaction. Then, we explored and cleaned the data, made possible thanks to interactive profiling. Following that, we were able to enrich and standardize the data thanks to intelligent execution. Bringing this full circle, we were able to take multiple complex data sets and transform them into a resulting set that could be easily digested and analyzed for creating our churn prediction model. Thank you for watching the Trifecta demo. In conclusion, I'd like to summarize the benefits we've seen for the companies who have adopted Trifecta. By providing a breakthrough user experience, Trifecta enables business users to access any form of data and prepare it in a consumable layout for their analysis. This can be done by themselves in a self-service approach, breaking the dependencies from IT or complex hand-coding languages. Productivity is drastically enhanced by an order of magnitude. Instead of frustrating cycles between IT and business to deliver and refine the data analyst can explore and validate the data with immediate feedback for the insight that he's looking for. By allowing the end user to clean and validate the data, the entire process is made more accurate and trustworthy. With correct information and trust in one's data, users lower the business risk in making decisions or implementing efficient data products. Less time cleaning data means more time analyzing data. Trifecta liberates users from the cumbersome process of preparing data so they can focus on higher value analytics problems. With a simplified data preparation process, users can augment the number of data points to unleash business innovation, take competitive leads, optimize operational efficiency, and reduce the cost of processes with a noticeable impact on the company's bottom line. It's now your turn to innovate with data. You can start wrangling now by downloading the Trifecta Wrangler free edition at trifecta.com/startwrangling. Thanks for watching.